All right, hope everybody's having a good day. Today we're going to finish up the rest of section 3.4. Yesterday we got started talking about functional notation. This was again the idea that we could offer names to different equations so that we could distinguish one from the other. So we've gone through that yesterday. Today, though, I just want to do a quick review. I know we did some of these yesterday as well, but I just want to make sure that everyone was okay again with, given a function, as an example, just make one up here. So if we have L of x, is equal to 3 times x plus 5, and we asked you to find L of 2, the idea is, once again, that we're going to replace x with 2 and then see what comes popping out for y. So what you're responsible for doing is taking the original function. So let me use my highlighter here just so I can highlight it for everybody. So you are responsible for taking the original function, so in this case 3x plus 5, and everywhere you see an x, replace it with a 2. I'm asking you to find L of 2. So everywhere you see an x, you're going to replace it with a 2. And then remember your PEMDAS from Algebra 1 class. All right, PEMDAS. We always multiply before we add. So here we have to do the multiplication. 3 times 2 is 6. Then do the addition. 6 plus 5 is 11. So if I write down what I started with, L of 2, and I write down what we get as a result, 11. Just want to remind everybody that the number that goes in is x, the number that comes out is a y. So this is just equivalent to the ordered pair 2 comma 11. All right, I'm going to slide the screen up a little bit and use the same function just to do another problem. So in this case I might ask you to do something like L of negative 4. The idea is exactly the same. Everywhere we see a variable in the original equation, the original function, we replace it with a negative 4. So again, back up. Everywhere we see an x, we replace it with negative 4. Again, I'm asking you to put in negative 4. So everywhere you see that x, you replace it with that number. And again, you guys will do the arithmetic. Remember, multiply before you add. So 3 times negative 4 is negative 12. Then negative 12 plus 5 is negative 7. So writing that out, this would then be L of negative 4 is equal to negative 7. What goes in is an x. What comes out is a y. So again, this is equivalent to the ordered pair, negative 4 comma negative 7. Okay, that's what we were up to yesterday. And again, I just wanted to do a few more of those to make sure we're okay on how we use functional notation. All right, given a function, we want you to be able to put in whatever values of x that we want. Okay, sometimes you guys get to choose the numbers that go in. Other times you'll be told which numbers to put in. Okay? Alrighty, so that's what we were up to yesterday. So I just wanted to do one more of those. Today we're just going to do a couple more things with functional notation. And I'm going to use an example to show you one of the things that we could do. I could give you a name of a function, so I could give you g of x is equal to 1/3 x minus 2. And instead of asking you to put in a value for x and see what comes out for g of x, we could essentially do it the other way around. So I could give you a function, and I could ask you to find x if g of x is equal to negative 4. All right? So instead of giving you the x value, what I'm giving you instead is the other one, which would then be if I'm not giving you the x, I'm then giving you the y value. So I'm giving you the y value, and we're going to ask you to find x. Okay? So essentially just the problem the other way around. So if I just scooch the original function down below, what I'm asking you to do here is replace the g of x with -4, right? Because we tell you g of x is equal to -4, so we replace g of x with -4. And we want you guys to then do the arithmetic to solve for x. In this case, how do you move a -2 to the other side? We would add. And how do you get rid of a 1/3 in front of a variable? You could divide, but if I don't want to use my calculator, what I would do instead is multiply both sides by the reciprocal. So I'm going to multiply both sides by 3/1 so that the 3's cancel. And what we get then is x is equal to 3 times -2 divided by 1, which is -6. So if we give you a function, we could essentially turn the problems around and ask you to find x given a functional value, which of course again is a y value. Okay? Feel free to pause the video if you need a little bit more time to look at one of the examples. Feel free, pause this. I'm just going to move on and try another problem. So here's another example of that same sort of thing. I'm going to give you the name of a function. I'll call this one w, and this time the function is going to be -3x plus 5. And I'm going to ask you to find x if w of x is equal to -7. So again, we're doing this the other way around because we're giving you the functional value and we're asking to find x. All right, so again, the way this works is we start with our original function. And we're going to replace w of x with what we tell you it's equal to. We tell you w of x is equal to -7. So we replace w of x with -7. And now I would ask you to then solve for x. You guys are pretty good at this algebra, so hopefully it'll go okay. How do you move +5 to the other side? Subtract 5. And how do you get rid of a times 3 attached to a variable? You divide. So that x is going to be equal to -12 divided by -3, which is +4. So the value of x when w of x is equal to -7 is 4. And if you just wanted to check yourself, if you're thinking, gosh darn, not sure if I did that right, what you could then do is put in 4 for x into the original function, put 4 in, and see if you really get -7 out. So let's try it. Let's put in 4 and see what we get. Again, multiply. Remember PEMDAS, so multiply first. -3 times 4 is -12. And then -12 plus 5 is -7. Yeah, that matches up. It's what we got out before. So we know that that has to be the correct answer. Okay? So that's one of the problems that we're going to use to finish off the rest of this section. We're going to ask you to find x when we give you a functional value. All right, so please practice that. All right, and the last thing that we're going to do here on section 4 with functional notation is we're going to combine functional notation with something we've done before, which is to graph a linear function. Right, so we're combining two things that we've done before. We've already graphed lines this year. In fact, in just the last week, I should say, not year. We've graphed lines in the last week. And now we're just essentially combining that with functional notation. So instead of asking you to graph y equals 2x plus 3, what we're going to do instead is we're going to ask you to graph f of x equals 2x plus 3. Hopefully that's not a big deal because we've been talking about how y equals and f of x are the same thing. Those are exactly the same thing. They mean the same thing in advanced math. So we're going to ask you to graph a linear function, a straight line, using the functional notation. So instead of an x, y table, we could have an x, f of x table. The idea is still the same. I'm going to ask you to find at least 3 points. And which variable is the independent variable here, like usual? It's It's the x variable. That's the independent one, so you guys get to choose anything you want. So just for the heck of it, I'm going to choose things like -2, I'm going to choose 0, and maybe I'll choose a 1. Okay, and what we're going to do is we're just simply going to put those numbers in for x. So we'll find f of -2, we'll find f of 0, and we'll find f of 1. We'll just put those numbers into the function. So everywhere you see an x, you put in -2. Everywhere you see an x, you put in 0. And everywhere you see an x, you put in 1. All right, feel free to use your calculators. I'm just doing these out loud. 2 times -2 is -4. And -4 plus 3 is -1. 2 times 0 is 0. And 0 plus 3 is 3. 2 times 1 is 2. And 2 plus 3 is 5. So very quickly, we get to 3 points. And now I'm just going to put enough tick marks on my picture so that I can get those 3 points. So -2, -1 is left 2, down 1. 0, 3 is stay in the middle and go up 3. 1, 5 is 1 to the right, and 5 up. And I'm just going to grab a ruler here so I can get a decent straight line through those 3 points. So it looks something like that. Hopefully the ruler didn't move much on my glass screen here, but there then would be the straight line through the 3 points for that function. So this would be the graph then of f of x equals 2x plus 3. Okay, so again, just combining that idea of drawing a straight line with functional notation, just putting those two things together, just putting those two darn things together. All right, so I want to do one more of those just to make sure we're okay on that. So one last example, and just for the heck of it, I'll give this a different name, so I'll call this one m of x. And this one I'm going to graph this function, -1/2 x, plus 4. Okay? So again, this is equivalent. This is essentially the same as if we would have last week drawn y equals -1/2 x plus 4. Those just mean the same thing. Okay? So all we're doing is instead of an x, y table, we'll just have an f of x table. And then we'll just draw the straight line that goes along with that function. Okay? Again, which variable is independent? Which one do you get to choose whatever the heck you want for? Well, of course, that's x again, like usual. And I'm just going to pick some numbers. But because the number sitting in front of the x is a fraction, please remember, you want to make this easy on yourself, so don't pick difficult numbers to work with. Pick easy numbers. And the easy numbers to work with here would be even numbers like -2, 0, +2. And those are easy because the 2 that's in the denominator, let me choose my little arrow tool here. There we go. The number that's in the denominator, the 2, will cancel when we put nice even numbers in. If we were to choose something like 3 to put in for x, then the 2 in the denominator is not going to cancel. So try to make things easy on yourself. Okay? So once again, what we're going to do is just simply find then m of -2, m of 0, and m of +2. That's what we're supposed to do. So again, that just means wherever you see an x, put in -2. Wherever you see an x, put in 0. And wherever you see, wherever you see an x, put in 2. Right? We'll just do that arithmetic. Again, feel free to use your calculator if you want to. -1/2 times -2 is +1, and 1 plus 4 is 5. -1/2 times 0 is 0, and 0 plus 4 is 4. -1/2 times 2 is -1, and -1 plus 4 is 3. And I'll put enough tick marks on my picture so that 2, 3, 4, 5, we can get our 3 points on our graph. So left 2, up 5. Stay in the middle, go up 4. Go right 2 and up 3. And again, I'm just going to use my ruler to try and get a decent straight line through those. So something like that, looks like my ruler slid a little bit, but you get the idea. Okay, and so that would be the linear function, the straight line, called m of x. Okay, so that's all we're up to today. A few more functional notation problems, and then just putting together straight lines with functional notation. Okay, so you have the rest of the hour then to work on that assignment, section 4. That'll be due tomorrow. So feel free to work on that, help each other out a little bit if you need to. And then we'll take care of questions on that one tomorrow in class. Okay? Hope you're having a good day, and we'll see you tomorrow. Bye.